So we have this this problem here, and the thing I said before was like I want you to break this down into what this actually means. What this means: derivative of tan of 3x. Okay, I don't want you to actually go through the limit process of solving that because it involves a lot of trig properties, and it would just be a waste of time. So it's best to translate this to what it actually means. It means the derivative of tan of 3x. Okay. So what rules, just by looking at this, just what's in red right here, what rules would we need to solve this? What derivative rules? You can just yell too. You don't need to, or just yell it out. You don't need to raise your hand or anything. Go ahead. Okay, it's definitely a trig rule, so transcendental. So we need to do the derivative of tangent. But what else? What else do we need? There's a couple more rules we need. Like what rule will we need for the 3x? Power rule, cool. And then what rule will we need for the fact that we have a function 3x inside of another function of tan? A function inside of a function, what rule? Yes. But do you know that now? Does everyone that didn't understand that now see that it's a function inside of a function? So a light bulb should be going off in your head. I need chain rule. You have to recognize that rule. It's like part of the thing of this class is just looking at it and going, what kind of pattern, what kind of generality can I use for this? What rule I can find? 3x is a function on its own. It's inside the tan function. Okay, it's not tan times 3x, so you cannot use product rule. That would not work because tan is not a function. I mean, it's a function, but tan is an operation really by itself. Does everyone see that? Yes, a little bit. Okay. All right. So here, I always say do the outside layer first. And I said, generally speaking, the outside layer is going to be the thing not in the parentheses. The inside layer is the parentheses. So if you want to think of it this way, if you were doing order of operations, what you would do last is what you want to do first with onion rule, with chain rule. Okay? So for this one, the outside layer would be the tan. So you're going to do the derivative of the tangent layer first. So this kind of begs the question, some people might not have memorized it yet, but what is the derivative of tangent x? Secant squared x, right? Tan x, the derivative is secant squared x. So we're going to use this fact to solve this problem. But watch this. This is kind of cool. There's a reason I picked this problem. Is let's just say you forgot what the derivative of tangent is. Here's a cool way of remembering it. Okay, you can actually do this for all of the trig functions. As long as you memorize 2 trig function derivatives, you can find all the other ones. And the 2 that you need to know is sine and cosine. So the derivative of sine is cosine. The derivative of cosine is negative sine. So as long as you know that, you can solve any of the other derivatives. I'm going to show you this right now. Well, the derivative of tangent x is the same thing as the derivative of sine x over cosine x. So we're dividing 2 functions. What rule can we use for this? Quotient rule. Who said that? You? Thanks for whispering it. Quotient rule. So now watch this. You can do gf prime. So g is on the bottom. So g times f prime. So cosine times the derivative of sine, which is cosine x. Okay. Minus f, which is sine x, times g prime, which is negative sine x. And then all of this is divided by g squared, which is the bottom squared. So it's cosine squared x. Okay. And check this out. This is insane. Plus, and at the very top, we have cosine squared plus sine squared. Cosine squared x plus sine squared x. What does that equal to? 1. Thank you. So now we end up with 1 divided by cosine squared x, which is 1 over cosine is secant. So you can rewrite this as secant squared x. Okay, you can do that with any of them. So say you forget what the cotan derivative is. You can just do cosine over sine and work out quotient rule. Okay, you can do this for cosecant, for secant, for anything else that you want, as long as you know the sine and the cosine. So if you remember the conceptual videos that I made, I only made the derivative of sine and cosine. All the other ones you can figure out from those 2, so I didn't want to go too much into the weeds on this, because really you don't need to know any of this if you just memorize it. But if your memory fails you, you're nervous during a test, you can, worst case scenario, you can just kind of prove it to yourself what the derivative is work it all out and get it that way. Okay, I think that's kind of cool. Okay, well, I know that was kind of a sidebar there. Sorry about that, but let's keep going with this. So first thing is you're going to do the derivative of the outside layer, which is the derivative of tangent. So you just write secant squared x. And if you notice, the 3x stays the same. So you have to do one layer at a time. Don't do all of them at once. If you wrote secant squared x of 3, that's wrong. Okay, you just write 3x and then you multiply by the next layer's derivative. So the next layer's derivative is going to be this 3x. What's the derivative of 3x? Anybody? 3. Okay, and then that's your final answer. This right here, which is B, it looks like. Now this problem could have started with the red where it says the derivative of tan 3x, but they wanted to test your understanding of, can you recognize the limit definition of derivative? Okay, and that's what the original problem is saying.